Okay, great, excellent. Good morning, ladies and gentlemen. It's my pleasure to be here today. I am Sophie Zurkia, and I'm the CEO of a company called Viridian. To make it confusing, we changed our name last year to Viridian. We used to be CGG, Compagnie Générale de Géophysique, and so we're a geoscience company, and we've been actuating in the oil and gas sector for more than 90 years, actually 94 years to be exact. So we've got a great deal of expertise in geoscience, and I'm here today to show you about how we can translate or we can reuse that expertise from the oil and gas and applying to the mining sector. Okay, so I've mentioned that Viridian is an advanced technology company. We're in digital, and we actuate in the field of natural resources, so oil and gas primarily. So 90% of our business is in these three core businesses. And so geoscience is where we do the imaging. So we take large amounts of geophysical data, seismic data, and we make very precise images of the subsurface in very complex environment, being on land or offshore, deep water, for example. The second business line is earth data. You're not going to be familiar with that business in the mining sector. It is where we invest our dollars and acquire data on our behalf, essentially geophysical data, but also it could be geological data, it could be public data, geochemistry data, well data. We put it together to create packages and information that helps the clients speed up their discovery cycle. And this is a business model, I have an example of that later on, that we're trying to apply to the mining sector. So we do have a complete data set for the mining sector in the US, and we've been experimenting with that business model. And the sensing and monitoring is where you have all the sensors, onshore, offshore, that are used to create those images to acquire the seismic data. So this is our core businesses, and of course, recognizing the energy transition and the fact that oil and gas might not be a growth value proposition for the long-term future, although it's very healthy and doing well right now. We wanted to find new revenues, new avenues of growth for the company for the future, and we looked at our capability and how we could apply those capability to other sectors. So we selected three areas where we're applying our expertise in technology. First one is low carbon. And in low carbon, you've got carbon sequestration, which is very straightforward from oil and gas. This is you're storing carbon deep down in the reservoirs. It could be aquifer or old oil and gas reservoirs. There's the minerals and mining, and that's going to be the topic of today. And so we've started these initiatives back in 21. So we're 3 years into all of those, and so we really are ramping up our expertise and understanding of what we can do in those various sectors. I have to say that last year in 2024, we started to see some very significant growth in those two sectors. So we started from a very low point in minerals and mining, but we more than doubled our revenue in that sector. Carbon was even more than that. The second area that we're looking at is digital. And in digital, we have two areas, is data transformation, data curation, data ingestion. Most companies that are dealing with subsurface data and different types of subsurface data are having a big data problem. So they don't know what data they have. It could be buried in documents. It's not always digital. It doesn't speak to each other. So everybody wants to do that AI thing. But in order to do AI, you have to have a good solid foundation of data, and data that is talking to each other, that is correlated with each other. Otherwise, you're not going to be able to get those insights. So we started that journey inside the company back in 2015 because we had loads of different types of data, geological data, geophysical data, and we wanted to start automating and being a lot more efficient at what we were doing. So when we realized that we developed tools, AI tools and systems and dashboards that were really helpful, we started to offer this to the market. So we're primarily, again, targeting our oil and gas clients, but I know there are discussions today with mining clients. So this is about making sense of your data, knowing what data you have, classifying, curating, classifying your data so that you can extract insights from it. The last one is infrastructure monitoring. It's a natural extension from the sensor side. It's repackaging sensors in order to provide solutions for health, structural health monitoring of, say, dams, bridges, been involved in mine tailings, into the structural health of mine tailings, so you can record vibration, or you can do the imaging side. And actually, it's interestingly, I saw the Saudi Railways was in this forum. We're working for Saudi Railways to identify cavities that are forming underneath the railways. So this is the imaging part, but the other part is the vibration and looking at natural vibration of infrastructures and inferring whether those infrastructures are getting older or having some kinds of problem, and some intervention is needed. Okay, so I did mention all the way, I should have talked about the HPC. The HPC, high performance computing, is an enabler in geoscience. It is more and more critical, and I think the whole, definitely oil and gas industry and more industries are trying to equip themselves with high performance computing, because with the amount of data exploding, AI exploding, you need that computing to get to what you need very quickly. It could be physics-based type of computing, which is a lot what we do. So people think we solve everything by AI. I like AI, it's a nice tool, but it's when you have physics is still the best tool to get you the right answer, but AI can come as a complement. But HPC is fundamental to get you these outcomes. So those are the capabilities that I would call it we developed, but then our industry, sort of the geoscience industry, had to develop to respond to the oil and gas problem that are directly applicable to these other sectors. That's the data. We have all kinds of data that we own, or technically that we have the right to market. So a lot of experience with data. Now, going into mining, and the objective of my talk today is to show you examples on how we've applied, or our journey into applying our technology and expertise into minerals and mining. So what is the problem? Of course, we work in a macro environment, so there are geopolitical drivers and issues. If you look at the industry itself is faced with the oil quality declining. Very similar story, I always refer to the oil and gas, but for the old timers in the oil and gas, some of them are here. Same story, that the easy oil was over decades ago, and more technology was required to be able to get to the next step. And similar story in minerals and mining, so oil quality is degrading, so better characterizations needs to happen. Exploration success is declining, and cycle time is increasing, which seems to be counterintuitive, that now with all the efficiency tools that companies have, that actually when you look at the numbers, the cycle time is increasing. Okay, said differently, geoscience and new technology is required to address these challenges. I should have mentioned here on that slide, there are different ways that the industry is responding to those challenges, including recycling, etc., buying companies. But really what we're talking about here is that bottom one, new technology and business models. So mining, as a result of the easy minerals having been found, it's getting more and more complex to find the new deposits, and therefore mining is getting deeper, more complex. And what we're seeing now is the limit of the old techniques, which is really drilling-based, core-based, and geochemistry-based. So I'm certainly not saying that drilling is not going to be there. Drilling needs to be there as a complement, but the more breadth of data you have, the better your answer will be, or better your understanding of the subsurface will be. So here that picture is just an example of the kind of drilling that happens to characterize or to explore and characterize reservoir, and you have numbers of exploration and discovery, which is sort of going down. And these are the challenges: exploration success declining, characterization is more difficult, and combined with that, all the industries are under scrutiny for the ESG performance. So you want to make sure you do things right, that you understand the rocks and the structure as you're digging, that you want to understand the hazards, You want to do things more optimally and reduce your footprint. So all of which geoscience can support. I'll skip that one. So if you look at, I wanted to give you some example and a feel for the kinds of solutions that do exist at various stages of the value chain. Again, it's not, people might think about geoscience and Earth data as just an exploration tool. It is a lot more than that. There's a lot to do, of course, logically in that next phase of appraisal to characterize the rocks. Now we can get the rock physics from the seismic data. Probably in the past that people have dealt with seismic thought this is essentially a structural, something to make an image and understand the layers and understand the faults, understand the structure, but it's a lot more than that. Now you can get the rock physics and the reservoir parameters from the seismic. Of course, you need some calibration points, and that's where the wells are going to be important. But it's also used in the all the way into the mining itself, and we had some projects with BHP that I will talk about, in which we've helped them identify new ore or bypassed ore that existed in their field that they hadn't seen previously, and so we were able to help them with that. So now going example by example, so this is first in the early stages, and this is where multiphysics is really important. So not so much necessarily the seismic side, but it starts with the gravity, the magnetics, and the electromagnetics, and the gradiometry. So bringing all these kinds of data together, possibly with some drilling data, some core data, chemistry data together to try and make sense of that subsurface and identify whether the area is of interest. So what's important in that stage is that you do this at scale, so that you could do this efficiency at scale, and then the data talks to each other, always correlated to each other. In other words, data leveling is extremely important in that stage. So this is just an example of what can be done. So you can use, I mentioned a lot of data. I forgot to talk about remote sensing. So there's a lot of information can be derived from those satellite images together maybe with this airborne type of data. And you bring it together, you could do spectral geology and start to get a view or first view of the surface layers and do quite a lot of interpretation from that. We have an example where mineral mapping was done over the entire Arabian Shield with that kind of technology. The other example I mentioned earlier was our Earth data example. This is our data library. So we invested our dollars in North America to create what we would consider a best-in-class geoscience data sets, so that the mining company could go running and really shorten that cycle. Because if every company does it, so this works really well and is a very well-established model in the oil and gas industry. But in the mining sector, it was sort of new, and we said, why not try it and see how it works? The US is very conducive because there's a lot of different players, so it's a multi-client model, so we invest and we sell the same data sets to different clients. And that's what we did. So we did it at large scale. We had the GravMag, gradiometry, airborne. We combined it with well data. We combined it with all data that was available together, and then made it in a consistent manner. So if you see something on one of the data sets, we could start looking at what it looks like in the other data sets and see whether that makes sense. So you get these levels of confirmation from the various data sets that are correlated with each other. Now, going into that sort of appraisal, planning and development, that discovery to mine operation can be over 15 years. In the oil and gas, in our core sector, in the oil and gas industry, typically you'd have 20 plus years, 20 to 30 years between discovery and first oil. Now, this has been the name of the game in the oil and gas industry. How do you get it shorter? And now some of the clients, ExxonMobil in Guyana, for example, got it down to 7 years. So that 15 to 20 years that used to be now is gone down to 5. How do they do that? they do that by investing earlier in better data. So ExxonMobil has acquired, 3D, extensive 3D seismic data from day one, where clients used to deal with 2D seismic data initially, and then it would take time to do the 3D. So everything takes time, right? So if you're trying to compress the cycle time, you need the best data from the beginning. Of course, you have to be cognizant that the budgets are the same. So probably the mining industry, the exploration budgets in the mining industry, I would call them, in the oil and gas industry, it's billions, it's 50 billions. Probably in the mining industry, you divide by, 3 or 4, that number, but still is not an insignificant number. And there are ways to acquire better data. So anything that you would do now would be better than what was done in the past. Because we've put our hands on some of the seismic data that had been acquired in the past. We would consider this sort of substandard in a way, and there would be a way for not a lot more expensive to acquire better data. It doesn't have to be the full-blown complex 3D and super expensive, but still better than what is being acquired today. And that's where those images of the subsurface are going to be very useful to define the ore body, to shorten that cycle, have that best data really early on, to optimize as well that planning and development. Because if you understand what you're dealing with, you could have a better suited, fit for purpose development plan and make sure you optimize your dollars from the beginning. Okay, so here's an oil and gas example, but we give you that example to show you what good technology is, or best-in-class technologies is in the oil and gas sector. So this is an example in Oman with hard rocks, and show you in a space of 3 years how technology has been advancing. So this is like what was considered a pretty good image back in 2020, and you look at it 3 years later, applying elastic full waveform imaging, which is really a more complete and a more fidelity into the physical model that we're using to derive the subsurface image. I mean, you could have a much better view of the structure, and even complex structure with high dips. Typically in the past, the seismic wasn't necessarily, surface seismic wasn't great at identify highly dipping structures, but with this kind of elastic full waveform imaging and the fidelity, you're starting to be able to do that. And so that was an example for oil and gas. And this one is I think it's definitely a mining example with sort of I would call it a low-end sort of seismic data set, but still applying best-in-class algorithmics and best-in-class processing, even to data that is sort of, not as rich as what we deal with in the oil and gas. You still get a much better understanding of subsurface. You understand where the ore body is. You see the basement. And then you also identify those shallower hazards, which is really important as you're going to make your development plans and you're going to start doing the drilling. So I guess that's the line that you see in here. This is what seismic was acquired, and you see the lines here. Now, going into more into that planning, development, and operations monitoring, this is really important to extract the rock physics. I alluded to it earlier, so it's not just about structure, but understanding the rock physics. Now, arguably, I've heard some mining players say, oh, it's very difficult to get rock physics for the mining sector. I suspect that as we look at the problem more and more and deeper, we could start identifying at least some signatures, right? I mean, we're not going to be complete 100% right, unless you have validation from a well. But if you have some well data calibration, if you now start understanding the signature of certain mining or certain ores, then I think you could start getting into understanding the deposits and understanding the ore structure. So that's just an example of a workflow where you start using all the geoscience and the geophysics that you have, multiphysics, seismic and putting it together and start deriving the elastic properties that are relevant for the mining. And so that's where you start looking at the porosity, permeability, the Young's modulus, and of course, the more calibration you have and the more understanding of that region you have, the better your result will be. But a lot of it can be data-driven if you have a good data set. So this is this is a testimony from BHP. They've actually presented this as a paper and they really, what they claim is what's underlined is better ore body knowledge facilitates more efficient mining and processing. So useful for, again, to think about the development and actually going into the mining itself. Now, what is it, there's always that price and cost and that sensitivity in the sector. Of course, it's not a perfect model, but there's a lot of drilling, and drilling's actually kind of expensive. If some of the drilling could be saved by having a better image, then you could save maybe 20% of the drilling, and that 20% you could reinvest in having this early upfront data. Then at the end of the day, you could still be better off and not make mistakes. And as you know, in any project, when you find something wrong later, it's more costly than when you find it early on, right? So the earlier you find about things, the better off you are, and so it avoids you to backtrack and change your development plans, and which is always, costly when it's late in the game. But of course, as a geoscience company, we like to see those nice images of the subsurface, and they're definitely quite impressive. And now going into that last operations side, you have to worry about the safety, and so I was talking about the hazards and the HSC side of things, but also you have to worry about the efficiency, and efficiency is about extracting the most ore you can with your OPEX, right? So you're spending money every day, can I get the most out of it? And so there are different solutions coming from the sector that are addressing those phases. And some of it, I'm not sure which one I have. Some of it is just the imaging, understanding the cavities, understanding the hazards. So this is more traditional geoscience or geophysics-based type of solutions. But there's others, as while you're drilling, imaging that, making images of that rock and identifying the ore. What we hear often is that as we're exploiting those mines, sometimes the ore disappears, and so you're trying to find where it is, and sometimes wasting dollars into trying to drill into different or dig into different parts of the mine to find where the ore is. So with imaging techniques, you can kind of in real time think that you would be able to image and understand where the ore is going, which is the equivalent in the oil and gas industry we call it well placement. And well placement is about drilling and putting the wells where the oil is. Here's about drilling and doing what you do in the mining sector, in the mining process, and really following where you have the highest grade ore and the best ore to extract most of it. I'll skip that one, and I'll finish on those thoughts, which is, we definitely see long-term demand for minerals and mining be very strong. Now the sector is sort of going through a trough, and which puts him in a mindset of a bit of a short-term mindset. But we think geoscience can address some of the challenges that we discussed earlier about that cycle time getting longer, the quality of the ore declining, the complexity of finding new ore, which is deeper and in more complex settings. Didn't elaborate too much on the data transformation, but that industry is dealing with a lot of data, the same as the oil and gas industry, and therefore having that data ready, talking to each other, de-siloed. Typically data is quite siloed, so connecting the data to each other, applying AI techniques to validate your thoughts, your geological thoughts, with different data sets is quite critical. And so data techniques and data transformation, AI can really help with that. And I think we do think, and that's why we're focusing on the minerals and mining, that definitely this is going to continue to develop over the years. And as we work with clients, that we'll be able to develop better suited solutions for the sector. But in general, I think our sort of geoscience industry has a big role to play for minerals and mining. So we'll look forward to it. Questions? Clear? All right. I'll just. Oh, there was one.
It was an excellent presentation.
Thank you.
Very insight about various aspects of data. My question to you is, as you have been saying that you acquire these data, you have been acquiring these data for American companies. Is there any plan to do something similar in Saudi, or is it going to be need-based, client-based data acquisition?
So it's so in general, when we do this in this model, this multi-client model, we put a project together where we feel multiple clients are interested. So you do need an environment in which multiple clients can play, can acquire land and access resources. So I'm not as familiar with the environment here, but for sure the environment in the U.S. is exactly that way. It's very easy to access the land, and there's a lot of clients, and because of the security, right, national security, there's a vibrant mining ecosystem over there. So that was a sort of a natural place to test a new business model. I have to admit and say we're looking for those clients. So right now, we're probably crossed the 50% funding for the project. So we invested X. So far, we sold to multiple clients, probably 3 or 4 clients, and we're about recovered half, which if I compare to the oil and gas industry, at the same stage, I would be probably 70 to 80% recovered. So it's the economics for us, of course, it's a much lower investment compared to the oil and gas industry. But we're testing the model, so we're pretty open to doing it in other parts of the world, provided that you have that ecosystem of clients. Or we could do it, sometimes this happens in a different way. We work with one client and they take the lead, so that client will invest. We don't invest, they invest, so they create that data set, and then they sell it to their partners. So you have different, but the idea is that because you federate a group of clients, you're able to do a lot better, right? Because instead of each investing on their postage stamps or on their little area, maybe different data sets, you have this kind of uniform view across. So it's actually should be quite cost effective. But what we find is that, our clients were not super comfortable with the model, very secretive. There's like, oh, do you mean like my competitor can have access to the same data? They can if they pay. But in reality, the value, I think, of a mining company is not the data itself, is what you do with the data and your knowledge, right? So the data should be okay that your competitor has access to the data, but what we're finding is many mining companies think the data is so important. It is, but you're better off having the best data set, shared across, and then that's where you add your value.
Just to add to this, since it's more local, so in the kingdom, do you gonna put a team of experts who have local knowledge of geology?
Yeah.
Or local?
Absolutely,
because
yeah.
Reinterpreting data with respect to local knowledge is critical.
Absolutely, no, we do recognize the importance of local knowledge. So we have a team on the ground, and we have a partner that in the kingdom that we'll be working with. So no, we do recognize, and so this is something we're familiar with because we need to work locally, and we need to work as a team with our clients as well, because clients have been doing this forever in their country and they know it better than us. But we bring the technology, they bring the local knowledge, and you put it together, it's very powerful.